So when I think of learning engineering, I think of other kinds of engineering metaphors. So, for example, chemical engineering, you would never build a new chemical factory or microbiological brewing facility or whatever using just chemists who are scientists who work in a lab and on small batches and all this. You have a whole field of chemical engineering of people who are, yes, committed to chemistry as a science, that yes, but they also have a wide range of other disciplinary areas to draw on. And they welcome and have studied and worked on other areas too, like health, safety, economics, feasibility, material science. Where are you going to put 1 million gallons of hydrofluoric acid? So a chemical engineer is someone who is working at scale on problems using the science to start from, but way more than that. Another analogy I like to use is civil engineering, where in much of what we do in ed tech, there's a sense of I've found a solution or the solution for this mathematics issue. Let's use it everywhere. And if you think about civil engineering as a discipline, you would never copy and paste a bridge from the Mississippi to now run across the Nile. You don't use the same bridge. What do? You go and study the context of where you're going to build a bridge, what's happening on the shores, what's the geology, also going out decades, what's going to happen with the weather or the river flow, of course, the usage, who's going to be on this bridge, traffic flows over time, weights, all of those things, weather. It's very different to build a bridge in Argentina than it is in, the tropics someplace, some other place. And so you then use science-based principles that have been around for a long time to design a bridge for that context that you've studied carefully. And you do not have to do everything from scratch. You have catalogs of components and parts and pieces that you then draw on to make an efficient bridge possible. And then finally, once you've constructed it, you monitor it, you study it. Is it working the way you intended, and so forth and so on. So in this sense, civil engineering is a very creative act. It's not like regimented. It's rather, there's a lot of principles of science. You have to understand the context really well. And there's still a lot of open field for what you're going to actually design within the constraints of the context and the constraints of the science. So to me, that's what learning engineering ought to be like. And then there are many kinds of practitioners, just like there are many kinds of physicians and many types and places to do civil engineering work. And so we need to get better at, yes, deeply understanding what we now know about cognitive science, motivational science, belonging, identity, the impact of stress on learning, even at a neurobiological level. That's the science part. But then you also have to, if you're going to do this work at scale in the field, you have to understand the context. Who are the people? What is the community? And then begin to do inclusive design, just like the best bridge building is done with the community, not to the community. So is the best learning engineering, where you work with the students and the teachers and the parents and the community to then figure out, given what we know about the science of learning, what's a fit for goals for the community and the students and the teachers and for affordances that are available and constraints for that community. So apologize, that was a slightly longer answer than you might have liked, but I wanted to try to give it more context because sometimes I know people say learning engineering. No, no, no. Teaching is an art. I don't want to be constrained by that kind of false science, right? And that's why the engineering metaphor is actually really appropriate because engineers are using science, but there's so many open variables and context specific issues that you have to be creative on top of the use of science, and then you may have to iterate and check and make sure it's working as you intended. So I